Hey guys, welcome to my YouTube channel, and today we're going to talk about turn signal switches. So if your turn signal switches don't work, the switch is usually the culprit. Today I'm going to show you how to test any turn signal switch, even if the wires don't make sense. You can do this on the bench like we're going to do today, or you can do it in the car itself. So I'm going to show you a cool little way to do that. So we have here is a couple different turn signal switches. We're just going to use this one for this test. Now, in order to test one of these without knowing what the wire colors are, even if you do and you're not sure if they're right, or if you're testing a switch just to make sure the switch is good, I'm going to show you a trick or method of how to do this without knowing what these colors are. So, first step is understanding how a turn signal switch works. So what you have here is you have three different positions that your turn signal can be in. One is the off position, second is when it's in the left turn position, and the third is in the right turn. So in this case, the switch is creating different sets of circuits. And so this is important to know because we're going to come back to this when we're figuring out exactly which wires do what. So let's go to the turn signal switch. So in this case, this is an aftermarket switch. It's one of those aftermarket hot rod switches you can get from any aftermarket place, but it's pretty indicative of what you're going to find in your application. In this case, this switch has 7 wires. So what I did was I went ahead and labeled them 1 through 7. Now I'm going to use this little piece of steel here just to help make this easier, and bear with me because what we're going to do here is I'm going to organize all these wires. Okay folks, so we got the turn signal lined up on the bench here, got all the wires in order so it's easier to show you what I'm doing, and the turn signal is in the off position. Now, all you need from an equipment standpoint to test this is either a multimeter, like this Fluke 179, one of my favorites, or a test light. And I'll leave links to both in the description, a couple that I think will work for you. Most people have it already, but if you don't, figure it can't hurt. You want to set if you're using a multimeter, you want to set either to the thing that looks like a speaker, which is your continuity, or ohms. With the ohms, it's nice to use the ohm setting if you're concerned you have a worn switch, meaning that it still works, but maybe doesn't work reliably, because that way you can actually see what the resistance is. A good switch, when you're in position, the things that are supposed to make connections should be very close to 0 ohms. If you have a couple wires that are bouncing all over the place, especially if you're manipulating the switch or wiggling the switch a little bit, that generally means your switch is worn and it's time to replace it. So let's get to work. So what I did here was I create a little template, a little chart, and do the same. Obviously this isn't fancy. And this allows us to put our notes in here. So let's rock and roll. So with the multimeter, first thing you want to do is just make sure that when you just touch the test leads together, or in this case a test light, that the light lights up. And in this case you can probably hear the noise in the background, and you want to have something that shows 0 ohms. Okay, so let's rock and roll. So let's start with number 1. So 1 and 2, nothing. We got connection on 3, we got connection on 4, nothing on 5, nothing on 6, nothing on 7. So we have 1, 3, and 4. So come over to our notes and put 1, 3, and 4. Thing I almost forgot. We got to test the other wires. So let's start with 2. So we have 2. We already tested 3 and 4. We know they connect to 1. So we go 2, 5, 6, 7. Nothing there. Skip over 3 and 4, 5, 6, 7, nothing there, and 6 and 7. So the reason why you want to do that is just to make sure that we know there's only supposed to be one circuit. Again, going back to this, which we'll get to in a second, in the off-center position, there just should be 3 wires that are connected together. Nothing else should be connected. So you want to do that just to double check that there's nothing else that is shorted in there or that's making a connection that shouldn't be. All right. So let's go to the left position. All right, so we're gonna do the same thing on the left turn position. Let's start at 1. So nothing, 1, 2, nothing. 3, 1 and 4 we have connection. Nothing on 5, nothing on 6, nothing on 7. So 1 and 4 have a connection, so we'll write that down. Okay, but we know other things need to connect as well from that diagram I showed earlier. So let's look to what else is connecting. 2, 2 and 3, 2, 3 and 5. So 2, double check. So 2, 3 and 5 are connected. Now we got 1, 2, 3, 4, 5. We'll just check to see if 6 and 7 are connected just for the fun of it, which they aren't. Wouldn't expect it. Now we'll go to the right turn and repeat the process. Again, starting back at 1. 1 and 2, nothing. 3, 4, 1 and 5, 1 and 6, and nothing on 7. So 1, 5, and 6. Write that down. 1, 5, and 6. Okay, we know we got something else out there, so let's go to 2. So 2, 3, 4, 5, 6, 7, nothing there. 3 and 4 we have a connection. You can see there, so 3 and 4. And then the only two we haven't really checked is 2 and 7. We'll just check those for fun. Nothing there. Okay, so one thing you may notice is, as we're running through this, is you see 1, 2, 3, 4, 5, 6. There's nothing on 7. Now this is one of those hot rod lights, and it has an actual light bulb inside the stock. And that light bulb is called a pilot light. So number 7, since it wasn't used here, number 7 is your pilot light circuit. So if you use a 3-pin flasher, which I'll get into on how to turn on the actual operation in a later video, that wire will be used. Now the other thing you say is, well, what about hazards? I have a hazard circuit. Well, a hazard would be another wire like this number 7 that's not going to light up in here. Now, one thing to note is you have to make sure you're testing this when the hazards are not activated. So most of the time, that's when the little hazard knob is pulled out, that the hazards aren't activated, or depending on your car, sometimes you push the button in to activate the hazard. So it's all car specific. But if you're testing these and you're getting more connections than what you see here, first of all, check to see that your hazards aren't activated. And if they are, deactivate them and run through them again. But your hazard circuit would be like this wire number 7, which isn't showing up anywhere in here. And then you can go ahead and test that by activating the hazards, and then you're going to get another set of numbers there. But for decoding the wires, you don't need to do that. All right, so let's now figure out what's what. We know we have a brake, a left rear, a right rear, turn signal power, right front, and left front. So we'll take the original picture that I put together. So when it's off, the brake input is going both to the left rear and the right rear. So that means that we have 1, 3, and 4. So that means that one is between 1, 3, and 4. One's the brake, one's the left rear, one's the right rear. Now we also know that when we turn left, the brake is only hitting the right rear, and that when we turn right, the brake is only hitting the left rear. So when we look at this, we have to look at what wire is common in all 3 of these. Now we know that there's just 2 wires connected here, 2 wires connected here. So those are that's your brake circuits. And we know that 3 are connected here when the turn signal is in the off. So if you look at this, what's common is 4 is common here, here, and here. So therefore, brakes are number 4. Now, brakes are 4, so let's just go ahead and circle that because we found that one. Now, between 1 and 3, we know that 1 and 3, one of them's the left rear and one of them's the right rear. But if we go here, we know that on left turn, the brake connects only to the right rear. So 4 is only connecting to the right rear. So the right rear is 1. And so we have that one. So therefore, what's left is the left rear. And the left rear happens to be 3. Now, the other thing you can see here is now you've actually started to decode the other parts of the circuit. So now we just have to figure out, now what we have both the left turn and the right turn, and as you can see, it's sort of the same thing. The turn in this case goes to 2 circuits, and also goes to 2 circuits here. So we have to find what's common between, which wire is common in both circuits. So if you look at this, we have 2, 3, 5, and then you have 1, 5, 6. What's common is 5. So 5 is the turn signal power. And then almost done. So on left turn, we know that we have 2, 3, and 5. 5 is the turn signal power. We know that 3 is already the left rear, therefore the left front has to be 2. And doing the same thing on the right turn, that leaves us with number 6, and then number 6 then has to be the right front. So and that is how you decode a turn signal. If you like content like this, please hit like and subscribe. I'll be doing much more content like this. Also, if you have any suggestions on how to, there you go, on anything that's blowing your mind, or anything that you're curious about, especially electrically, automotive electrically, please put a comment in there. I'd love to hear what you think, and you'll be seeing more content from me here real soon. Thanks again for all your time and all your support, and I hope you have a great day.